Hello my dear students, in this class we are going to discuss about the formation of ethane molecule, which is an example for sp2 hybridization. So the formation of ethane is explained on the basis of valence bond theory. So for this we have to consider the molecular formula of ethane. So the molecular formula of ethane is C2H4. That means there are 2 carbon atoms and 4 hydrogen atoms. So each carbon atom is attached to 2 hydrogen atoms. Okay, that means one carbon atom is attached to 2 hydrogen atoms. The other carbon atom is also attached to 2 hydrogen atoms. So the formation of ethene is explained using the valence bond theory. So for this we have to see the electronic configuration of the carbon atom in the ground state. That is 1s2, 2s2, 2p2. Okay, so if you represent these orbitals in the form of box, you can see here this is 1s orbital with the 2 electrons, this is the 2s orbital with the 2 electrons, and these are the 2p orbitals containing 2 electrons. So filling up of electron in the 2p orbitals is taking place according to the Hund's rule. Okay, so according to Hund's rule, no pairing of electron will take place in the p, d and f orbitals until each orbital gets a 1 electron. So here there are only 2 electrons. So here one orbital gets 1 electron and the other electron is filled in the second 2p orbital. So for that reason there are 2 unpaired electrons here in the ground state of carbon atom. Now look at the electron configuration of carbon in the excited state. In the excited state it is 1s2, 2s1 and 2p3. Okay, so you can compare electron configuration in the ground state and excited state. In the ground state 1s2, 2s2, 2p2. Here it is 1s2, 2s1, 2p3. That means 1 electron from here 2s orbital is promoted to vacant 2p orbital. Here this among these 2 electrons, 1 electron is promoted to vacant 2p orbital. So that there are 4 unpaired electrons in the excited state of carbon atom. In the excited state you have 2 electrons in the 1s orbital and 1 electron in the 2s orbital. That means among the 2 electrons, 1 electron from 2s orbital is promoted to vacant 2p orbital. So for that reason 2s orbital has 1 electron and here 2p orbitals have 1 electron each. So there are 4 unpaired electrons in the excited state of carbon atom. So the valence of carbon is 4. Okay, there are 4 unpaired electrons, so that the valence of carbon is 4. Okay, and hence it is said to be tetravalent. Tetra means 4. So tetravalent means the valence of carbon is said to be 4. Okay. Now before actually the bonds are formed between carbon and hydrogen atom, so sp2 hybridization will take place in each carbon atom. Each carbon atom in ethene is sp2 hybridized. Okay. Now we shall see which orbital will undergo hybridization. 2s orbital and 2p orbitals undergo sp2 hybridization. So sp2 hybridization involves mixing up of 1s orbital and 2p orbitals. Okay, only 1s orbital, but 2p orbitals will mix with each other to form the new orbitals known as sp2 hybrid orbitals. Okay, now 2s orbital, that is 1 s orbital and 2p orbitals, they mix with each other to form the 3 new identical orbitals known as sp2 hybrid orbitals. Okay, you know that the number of new orbitals formed will be equal to the number of atomic orbitals mixing with each other. So here 3 orbitals are mixing with each other. There is a 1 2s orbital and 2p orbitals. So totally 3 atomic orbitals are mixing. So you will get 3 new orbitals. So they are known as the hybrid orbitals, and they are all identical with respect to energy and shape. Okay. So since only 2p orbitals are mixing, so there will be another 2p orbital also which is not hybridized. Totally there are 3 p orbitals. Out of the 3 p orbitals, 2 are mixing, but the third one do not mix. So the remaining one 2p orbital does not undergo hybridization. That means it will not mix with the 2s orbital. It will remain as it is. So it is said to be unhybridized. The orbital which is not undergoing hybridization is known as the unhybridized orbital. Okay. Now totally 3 new hybrid orbitals are formed, and these 3 are known as a sp2 hybrid orbitals, and each carbon contains one unhybridized 2p orbital. Okay. Each carbon contains 3 sp2 hybrid orbitals and one unhybridized 2p orbital, and all of them contain 1 electron each. Okay, that means the 3 sp2 hybrid orbitals each will contain 1 electron, and unhybridized 2p orbital also contain 1 electron. Okay. Now these 3 sp2 hybrid orbitals, they will be lying in the same plane. They lie in the same plane at an angle of 120 degrees. That means the angle between the hybrid orbitals is 120 degrees, and they are directed towards the corners of the equilateral triangle with the nucleus at the center. Okay. If you assume that nucleus is at the center of the equilateral triangle, the 3 hybrid orbitals will be directed towards the corners of the equilateral triangle, and unhybridized 2p orbital will be perpendicular to plane of these 3 sp2 hybrid orbitals. You can see here the picture. So this is 1s orbital, and these are 2p orbitals. They mix with each other. Totally 3 are mixing. So 3 new hybrid orbitals will be formed. So these are the new orbitals. They are known as the hybrid orbitals. Each one is called sp2 hybrid orbitals. So they are in the same plane. Okay. And the unhybridized p orbital will be perpendicular to plane of these 3. Okay. You know that both the carbon atoms in ethene are sp2 hybridized. Now those 2 sp2 hybridized carbon atoms, they approach each other. They come close to each other. Okay. So among the 3 sp2 hybrid orbitals, 1 sp2 hybrid orbital of each carbon atom overlap along the axis to form the carbon to carbon sigma bond. Okay. Totally each carbon has 3 sp2 hybrid orbitals. Out of the 3 sp2 hybrid orbitals, 1 sp2 hybrid orbital of each carbon atom overlap along the axis to form carbon-carbon sigma bond. This bond is between carbon and carbon, that is formed by overlapping of sp2 hybrid orbital of one carbon atom with sp2 hybrid orbital of another carbon atom. This is the bond between carbon and carbon. Okay. Now after this, the remaining 2 sp2 hybrid orbitals of each carbon atom. Okay. So when one is involved in overlapping with the sp2 hybrid orbital of another carbon atom, each carbon atom will have 2 sp2 hybrid orbitals. Okay. Now these 2 remaining sp2 hybrid orbitals in each carbon atom overlap along the axis with the half-filled s orbital of the hydrogen atom to form 2 carbon to hydrogen sigma bonds. Okay. So two bonds are formed because each carbon atom is bonded to two hydrogen atoms. So two bonds are formed here between carbon and hydrogen. Okay. After this, each carbon atom has one unorbital 2p orbital. Okay. Now this unorbital 2p orbital overlaps sidewise with the unorbital 2p orbital of another carbon atom. Okay. Unorbital 2p orbital of one carbon atom and unorbital 2p orbital of another carbon atom overlap sidewise to form the carbon-carbon pi bond. Okay. So this pi bond is formed by sidewise overlapping of the unorbital p orbital. Remember this. And carbon-carbon sigma bond is formed by axial overlapping of the sp2 hybrid orbitals. Okay. That's how the bonds are formed between carbon and carbon. Sigma bond between carbon and carbon is formed by axial overlapping of sp2 hybrid orbitals from each carbon atom, and pi bond between carbon atom is formed by sidewise overlapping of unorbital 2p orbital of each carbon atom. Okay. And bond with hydrogen atoms are formed by overlapping of sp2 hybrid orbital of carbon and half-filled s orbital of the hydrogen atom. Okay, you can see the orbital picture of this. Okay, now these are the two carbon atoms. This is one carbon atom with the three sp2 hybrid orbitals. This is the nucleus of one carbon atom, and this is second carbon atom with a nucleus here at the center, and these are the three sp2 hybrid orbitals of this carbon atom. These are three sp2 hybrid orbital of this carbon atom, and these are three sp2 hybrid orbital of this carbon atom, and these are the unorbital p orbital. They are lying perpendicular to plane of the three hybrid orbitals. These are all lying in the same plane, and these are also lying in the same plane, but these are p orbitals. These are p orbitals, they are not hybridized. So they will be perpendicular to plane of these three sp2 hybrid orbitals. Okay. Now here sp2 hybrid orbital of one carbon atom, sp2 hybrid orbital of another carbon atom overlap along the axis to form this bond. This carbon-carbon sigma bond. This is the carbon-carbon sigma bond. Here there is double bond between two carbon atoms. One is the sigma bond, other is the pi bond. Now this sigma bond is formed by overlapping of sp2 hybrid orbital of one carbon atom and sp2 hybrid orbital of another carbon atom along the axis. So they overlap along the axis, that is known as the axial overlapping. So axial overlapping of the two sp2 hybrid orbitals from each carbon atom results in forming the sigma bond. Okay, this is one. Our remaining two sp2 hybrid orbitals, they overlap with the half-filled s orbital of the two hydrogen atom. Now this sp2 hybrid orbital of this carbon atom overlap with the half-filled s orbital of one hydrogen atom, and this another sp2 hybrid orbital of this carbon atom overlap along the axis with the half-filled s orbital of the second hydrogen atom. So in this way these two bonds are formed here between carbon and this hydrogen, this carbon and this hydrogen. Similarly, the remaining two sp2 hybrid orbital of the second carbon atom, each one overlapping with the half-filled s orbital of the hydrogen atom. Now this sp2 hybrid orbital of this carbon overlap with the half-filled s orbital of this hydrogen atom to form this CH bond. Similarly, this sp2 hybrid orbital overlap along the axis with the half-filled s orbital of this hydrogen atom. So in this way, these carbon to hydrogen bonds are formed. This is one carbon to hydrogen bond. This is another carbon to hydrogen bond. Similarly, this is third carbon to hydrogen bond, and this is fourth carbon to hydrogen bond. Okay. Now these p orbitals, they overlap sidewise. Okay, the pi bond that is formed here, that is formed by overlapping of unorbital p orbital sidewise. They overlap sidewise, or lateral overlapping of these unorbital 2p orbital will result in forming the pi bond. So in this way the bonds are formed. between carbon-carbon and carbon-hydrogen atoms. Okay. Dear students, now we can conclude about the structure of the ethene molecule or the shape of the ethene molecule. There is a trigonal planar. Okay, it is having the trigonal planar structure or flat planar structure. Okay, and the bond angle is a 120 degrees. Is the bond angle in ethene. We can find that it is 120 degrees because the three hybrid orbitals are oriented at an angle of 120 degrees. So for that reason, bond angle is a 120 degrees, and bond length between carbon and carbon, that is 134 picometers. It is a 134 picometer. That is a double bond length because there is double bond between two carbon atoms in ethene. So this bond length is the carbon-carbon double bond length in ethene, that is a 134 picometers. Then you know that each carbon atom in ethene is a sp2 hybrid. So the type of hybridization of carbon is a sp2, and the number of sigma bonds totally it is equal to 5. Okay, so 1 sigma bond between carbon and carbon, and 4 sigma bonds between carbon and hydrogen atoms. Now there are 4 hydrogen atoms, so each carbon atom is bonded to 2 hydrogen atoms. So 2 plus 2, that is a 4 carbon to hydrogen bonds are there. All these are the sigma bonds. 1 bond between carbon and carbon and 4 bonds between carbon and hydrogen, altogether 5 sigma bonds, and number of pi bond is only 1, that is between carbon and carbon. Okay, that means out of the double bond between carbon atoms, one of the bonds is sigma bond, the other bond is a pi bond. Okay, 1 sigma bond and 1 pi bond is formed between the 2 carbon atoms. You can see the picture of the ethene molecule here. These are the 2 p orbitals that are perpendicular to the plane of 3 sp2 hybrid orbitals, and they are parallel to each other. So they are overlapping sideways to form the pi bond. Okay, these overlapping sideways to form the pi bond, and these are the sp2 hybrid orbitals overlapping along the axis to form the sigma bond. This is sigma bond between 2 carbon atoms, and this is a pi bond between 2 carbon atoms. So the double bond between the carbon atoms is formed in this way. Now these are the hydrogen atoms. Now this is 1 carbon to hydrogen bond, that is sigma bond. This is another carbon to hydrogen bond, there is also a sigma bond. So 1 and 2 here, these 2 are sigma bonds. Similarly here also, this is a 1 bond between carbon and hydrogen. Similarly, this is another bond between this carbon and hydrogen atom. So 1, 2, 3, 4. These bonds between carbon and hydrogen are sigma bonds, and this is another sigma bond between carbon and carbon. So that is altogether 5 sigma bonds, and 1 pi bond existing between the 2 carbon atoms, that is formed by sidewise overlapping of a unhybridized p orbital. Okay, sidewise overlapping will take place between the unhybridized p orbital, and that forms the pi bond. This is the orbital structure of the ethene molecule that we can represent. Okay, I hope you have understood how the ethene molecule is formed. That is explained on the basis of valence bond theory. So these are the bond parameters, that is shape of the molecule, bond parameters, that is bond angle, bond length. Okay, so bond angle is 120 degrees and bond length is 134 picometer, that is a double bond length. Okay, so this question will be asked for 3 marks in the examination, sometime about 4 marks. Okay, explain the formation of ethene molecule using the concept of hybridization, that will be for 3 or 4 marks. Okay, so here I have given the questions. Okay, please watch the video till the end so that you can observe the questions, both the MCQ and the short and long answer type of questions. Okay, I hope you understood how the ethene molecule is formed. That is explained on the basis of valence bond theory. Okay, so this is very important even in the NEET examination or the annual examination or a CET examination. Okay, so if you have any doubts, you can put the question in the comment box. For any clarification also, you can put in the comment box. So thank you very much and wish you all the best.